Have you ever sliced an apple, left it on the table for a while, and noticed it slowly turning brown? Most of us see this almost every day, but we rarely stop to think about why it happens. That simple color change is actually the result of a chemical reaction happening right in front of us. In this video, we are going to take that everyday observation and break it down using chemistry. We look at what causes oxidative browning in apples and how chemical kinetics helps us understand why the browning happens faster under certain conditions. So first, let's start by understanding what oxidative browning actually is and what chemical components inside an apple are responsible for this reaction.
So what is actually oxidative browning? Oxidative browning is a chemical reaction that causes apple to turn brown shortly after being cut, bitten or damaged. It is an enzyme catalyst oxidation reaction that involves polyphenol oxidase, which is PPO, acting on naturally occurring phenolic compound in apple flesh. The experiment that related to oxidative of browning apple, we can prepare the material. We need to have apples, vinegar, diet cola, lemon juice, apple juice, and few of small plastic cup and knife. First, cut the apple into several thin slices, then put into a different cups. The second step is leave apple slice in the different liquid for around 1 hour, and then we remove each apple slice from the liquid and inspect them carefully. And really important is take the observation of it. So from the experiment, we have some question that related to the experiment, which is first is which of the apple slice is more brown after 1 hour, and the second which is least brown, and third what makes the apple slice brown over time, and then lastly why does the apple slice in the lemon juice brown more slowly. So the first answer, the apple slice in water or Coke is usually the most brown. Coke is acidic, but its dark color make the apple look even more brown. So for the answer for the second question, the slice in lemon juice is less brown. It is because lemon juice has a high amount of vitamin C, which is vitamin C is a ascorbic acid that will slow the oxidation. And the answer for the question 3, apple turn brown because of oxidation. When the apple is cut, oxygen in the air react with enzyme inside the fruit that we call polyphenol oxidase. This reaction produces brown color compound. Lastly, it is because lemon juice is acidic and contain vitamin C. Most of this stop or slow the oxidation reaction. The acid lower the pH, so the browning enzyme become less active. So for this slide is an overview of reaction mechanism that can be known from the experiment. For the reaction mechanism, the first step is when the cathinol bind to polyphenol oxidase active site. It is because polyphenol oxidase contain 2 copper ion and catechol coordinates to Cu2+ via its 2OH group. And the second, when the oxygen bind to compass center, because oxygen is activated by Cu2+, and this activated oxygen pull electron from catechol. The third step is oxygen occurs, which is catechol lose 2 electron and 2 proton. This makes the electron will reduce oxygen to the hydrogen. The fourth step is formation of orthobenzoquinone OH group on the catechol becomes C double bond O, and aromatic ring becomes a quinone, which is a color compound. Last process of browning apple or oxidized apple is polymerization. How it undergo? Orthobenzoquinone will undergo nucleophilic attack by amino acid, and the polymerization process with other quinone and the condensation process with phenolic compound. This will make happen apple to turn brown in color, or we can say that apple have oxidized.
Next, we will explain the kinetic concepts applied in this reaction, which is the red law. The first one is first order reaction, and the second one is power law, Weibulian model. For first order reaction, the equation is delta ET equals to B times 1 minus exponent to the power of negative KT, or concentration of AT equals to concentration of A naught times exponent to the power of negative KT. The integrated law of first order can be expressed in terms of a measurable property browning index that calculate the formation of browning pigment on the surface of apple. Next, we go to the power law Weibulian model. The equation is LT equals to L naught minus K times T to the power of N. This model can measure the color parameter of a sliced apple that been exposed will form a brown pigment. Also, it can treat as a pseudo-order reaction where the order and the rate constant are experimentally determined. Next, we will figure out together on how the reaction impacts industry, environment and biology. So, how the reaction impacts industry? The reaction can impact industry because there will be food quality drop. It is because the browning makes the apple appear spoiled. And if the look of the apple looks spoiled, the customer will not buy the food because it looks bad and rotten. The next impact is there will be economic loss. It is because when no customer buy the product, the sale will drop because of the product rejection. And companies must spend some money to avoid or reduce the browning on the products. Next, how the reaction impacts the environment. So the reaction can impact the environment because there will be food waste issue. Browning will make the product unattractive. So when they are unattractive, the customer will not buy them. So when no one is buying them, it will lead them to being thrown away. As a result, it will increase the carbon footprint due to the waste of resources such as water and land. The next impact is energy consumption. For your information, there are several methods that have been used to prevent browning. For example, cold storage, blanching, and modified atmosphere packaging. So, these methods require lots of energy. When there are lots of energy being used, it will lead to large carbon emission. Next, we go to the last part, on how the reaction impacts biology. The first one is plant's defense. Actually, browning reaction is an act of defense mechanism in plant. It is because browning reaction involve quinones. So, quinones on apple prevent bacteria or fungi to enter the damaged tissue because it have antimicrobial properties. And the last impact is there will be nutrient change. It is because when a fruit going through browning reaction, the vitamin C content in it will be reduced through oxidation. Other than that, it can also alter the taste of the food.
To conclude, apple browning happens because enzymes use oxygen to oxidize phenolic compounds into quinones, which then form brown pigments. By understanding the chemistry and kinetics behind this reaction, we can better control browning in food processing and daily life.